Welcome back to Gappleton. Today we're going to be doing a little bit of a CNC plasma cutting. This is going to be part 2 of our 4-link build. So, as we may have discussed last time, the 4-link brackets that I previously made, they're not quite all trued up and square. The holes came out a little bit oval shaped, and this hole is a little too small for my axle, so I'm going to be cutting out a new set of these rear brackets. So this is a great time to talk a little bit about the table that I built. So this is it. This table is all my own design, top to bottom. I kind of just developed this as I went along. It's made out of an 80-20 style aluminum extrusion system, which I actually sourced through work. All the pieces of aluminum and all the bracketry and whatnot. Yeah. So this table is an Ethernet-based machine as opposed to other CNC systems that run off of a USB connection to a laptop. So inside here, here's my control panel. All of this I put together myself. Down here we have a large power supply on the bottom left. The top right, those are all of my motor drivers. Another power supply, torch light controller, breaker and surge protection, power distribution. And then up top, we have the Pokey's 57 CNC breakout board. And I really like this board being that it's Ethernet based. Ethernet is much better for the plasma cutting environment. So plasma it's a very noisy process as far as CNC goes. And the Ethernet based machines just seem to have less communication issues than other USB type machines, just with electrical noise and whatnot. So connects from the table down here through an Ethernet port up to my laptop where I'm running Mach 3. So we come over here and open up Mach 3. Ignore this warning, it's not important. Go away. And we're up. So now I go over here, I load the G-code file. Let's see. I want to look at my USB drive because I have a folder made for 4-link stuff. 4-link files. And let's try this first top doubler. So we'll open this up. Pulls it up, you can see the plate over there. And yeah, once the table's all set up, I still have to turn the plasma cutter on, which is housed underneath right there. Air, plasma, make sure the table's squared up and stuff like that before I start. Then all I have to do is hit reset and go. So I have my file loaded. I moved my machine over to the corner of a spot where I know I can squeeze out this piece out of this piece of steel that's down there. So I centered off of a corner down there. Then go out, zero out the machine because it's going to start cutting right down there, And yeah, all I have to do is hit go. And here's that piece. This is right off the table. So as you can see, maybe, the cut is pretty straight. Sometimes something you fight a lot of times is the cut of the plasma actually being tilted or slanted. So I think I have this pretty well trued up. I'm going to measure up these holes real quick. As you can see, these are 1/2-inch holes, and yeah, that is pretty spot on. That's something I can live with. So yeah, just make sure that the bolts from the 4-link will fit through there. These are surprisingly round. I'm really happy with this. Alrighty, quick little kiss with the 1/2-inch drill, and these bolts go right through. Now, I'm not going to bother making any adjustments here. I'm just going to build these parts as is, and then I will take the drill and chase all these holes when I'm done. Doing perfectly round bolt holes is actually something really, really difficult to do. So rather than chase a perfect hole with the plasma, I'm just going to make these parts as they come off the table and chase the hole with the drill. That way I'm getting my nice round holes post-process of the table. And here we have 4 of those doubler plates. That's that doubler plate for that position there. All 4 of these made, 2 per each bracket. So yeah, moving on. I'm going to cut this doubler next and then this. I don't know if I'll make it to cutting the 1/4 inch today, but yeah, get all these doublers zapped out while the table's running good. There you have it, folks. We got all of the doublers all fried out. These are the shocks right there. These bigger ones go here. This bigger one is actually shared by the front bracket as well, so that's why there's twice as many of them cut out. And then obviously the small one goes up there. So the only thing left to print out or recreate is going to be these ones here. This goes on the front of the bolt holes, and you'll see when I cut out those later. These are going to get recreated as well because these were also cut back before the table was trued up. So yeah. Now I just need to cut out the 1/4-inch main plate, and these can all get welded together. All right, today's tomorrow. We're going to try and get some of, those main brackets cut out. We're going to start with one, do all of our measurements, see if it's good file, good settings, everything's good to go, and then cut out 3 more. So let's hit it. All right, this part looks sweet. I am super happy with the way this cut. All of these cut lines are very perpendicular, which I'm super happy about. Let's see. So this is supposed to be 1 1/8 inches. Let's see, I don't know if you can see that like I can. But yeah, we are spot on at 1 1/8 inches. So it's a 3-inch axle tube, 3 1/8, sorry. 3-inch axle tube, and I wanted a little bit of gap just for easy fitment and a good groove to weld in. This thing is looking killer. Let's check the bolt holes while we're at it. You know what, those might have to get chased with the, oh, that's 1/2 inch. Let's see if it picks up like it wants. Yeah, got 1/2 inch holes. These ones are 1 5/8 inches. So I can run a pipe through there, which I have sitting over here, that bigger stuff, for some support. Yeah, I think this is gonna be killer. The tables all seems to be pretty well dialed. I am really excited. I get to go cut out 3 more of these and weld on these doublers. Keeping the project moving. Let's get after it. So you want to know how I know these turned out way better, this part right here? Because this is actually all 4 plates. They are perfect copies of each other. Yeah, they are really, really, really good. I am super happy with how this turned out. Yeah, this is killer. Something I do want to do for the future. I do really need to get the water working for the table. I have a pump and reservoir for coolant under the table. It's just not filled right now. I'm gonna replace the pan because at this point I've burned a bunch of holes in it, so I need to get a new pan made. I have a really nice neighbor who does HVAC work, and he made this pan and did a super, super good job. So I'm gonna have him make me another one. Yeah, that's gonna help with smoke in the garage. That's gonna help with the overall material warpage. If you think about it, the very first part I cut when the plate is dead cold is probably gonna be more exact than by the time I cut my last part, like 1 through 4. Number 1's gonna be spot on. Number 4, the plate's gonna be a lot hotter when I cut it, so it's potential to shrink back and actually end up a little small after it's fully cooled after being cut out. Having the coolant in the table is gonna keep that part cool a lot longer throughout the process. The plate itself isn't gonna heat up. So that's something I do wanna get done. I'll probably get that done before I cut out the rest of the brackets for the rear, the big tomahawk style one. So I may be jumping ahead a little bit here. I'm not sure where I left off in my last bit of filming, but this is kind of my setup for welding on these doubler plates. You can see I have them bolted down tight. There's one already partially welded on the backside there. So I'm trying to avoid warping these 2 plates because that's what happened last time. So what I'm doing is I have them bolted, all the layers are bolted together. This is doing multiple things. So this is ensuring proper alignment between the doubler plate and the main plate, and it's also ensuring proper alignment between the 2 plates themselves, like the two halves that make up the pair. So having everything bolted together, I'm hoping nothing warps. I'm stitch welding this, maybe doing 1 inch at a time and moving around. I already have a setup down there cooling. So what I'm doing is doing about 1 inch, switching to a different portion of the part, and then switching parts completely between the two pairs in hopes of not warping these plates. Axle plates are fully welded. They are completely done. Now what I did, I kind of jumped ahead, but when I did that doubler right there, the long one for the shock mounts, I kept everything fully clamped. Well, this was sitting in the vise, but I kept everything clamped up while I welded, because at that point, the scrap brackets, you probably won't be able to see it, that's where they wandered off, is when I did that long strap down the side. I poured way too much heat into the part. But as you can see this go around, I took my time. You can see all my stops and starts. Yeah, I played around a little bit with some pulse welding. You can see it looks a little bit more consistent when you get towards the end of the part here on the left-hand side right there, as opposed to there. I was just straight welding, whereas over here I started to pulse. Still trying to learn the TIG machine. It's got more dials than I know what to do with, so I am getting there. Yeah. Making improvements. So now I'm going to cut all the tacks off, because what I did here was I actually built these in pairs. So I had a left and a right, I sandwiched them and I aligned all the holes the whole way, and I welded them in pairs with the holes all aligned, just as a means to keep things all lined up. So now I get to cut those tacks and see what we did. Throughout this process, something I was really scared of was getting to this point, cutting these tacks and having the parts kind of spring off as I release all the tacks and what's holding them together. So as I get through here, this point was pretty exciting for me as I finally popped these apart and stared down the end of them. Really excited to see that they didn't move or didn't go anywhere. All right. I don't know how well you can see this, but these are actually pretty straight. These are much straighter than the last ones. So I think all of my efforts of building these as a matching set pair, I think it paid off. All right, these also passed the flatness test as good enough for who it's for. Pretty much maybe a tiny bit of weeble wobble. But yeah, overall, way flatter than the old ones. All right, there it is. This is the finished for now 4-link in all of its goodness. Now, I say finished for now because what needs to happen next is I need to take the bed of the truck off and actually start fitting up this 4-link to what's in the truck right now. And the reason I haven't been able to cut these brackets out yet is because this bracket, or this set of brackets, is actually going to be intersected by a cross member that I have to build. And part of that cross member, so it's going to be a bracket. Between there's going to be a drive shaft hoop, and I also have to integrate in the wishbone, which is what locates the axle left to right. It's a Y-shaped piece with a telescoping end on it, so it allows the suspension to articulate, but it still locates the axle left and right to the truck to keep it centered. So the next step is going to be pulling the bed off of the truck and starting to mock up what this is going to look like in the truck. It's going to involve a lot of use of our sacrificial templates to kind of get things as measured up as best we can before we actually start cutting and grinding, because it's going to be a big project. This is a milestone for sure, and I'm glad to have it done. I'm really happy with how this is turning out so far, and I'm really excited for what it's going to do for the truck. So that's going to end it off for this portion of our C10 4-link build. Stay tuned next time where we get into the meat of her. Thanks for watching.